Guys, today we're going to talk about some applications using quadratics, the things that we have learned so far. We're going to kind of put everything together that we've done in the previous 2 units. So we want to think about a couple of things to go over before we start looking at some of these applications. A couple of things I want to remind you of. First of all, if we are trying to find the vertex of a quadratic, then I just want to make sure we've written down the formula again. To find the x-coordinate, we take negative b over 2a, and to find the y-coordinate, we just plug back into the function whatever we got for the x-coordinate. So whatever that negative b over 2a is, we plug back in. A couple of other things I just want to quickly remind you of. If you have your quadratic, depending on which way the parabola opens, okay, we could open up, we could open down, okay? Your vertex is either your highest or your lowest point. So your vertex is either your minimum point if we are opening up, or your maximum point if we are opening down. Also, let's say that we need to find intercepts. Remember, to find the x-intercept, we want to plug in 0, set the whole equation equal to 0, so we're plugging in 0 for y, and we can solve by either factoring if that's possible, or quadratic formula. Okay, y-intercept, just in case we would need that. Remember, that's really easy. That's your c value. That's when x is equal to 0. So if you have ax squared plus bx plus c, c is your y-intercept. Okay, now let's take a look at some examples of what this might look like whenever we have quadratic applications. Here's our first question. A model is launched from the roof of a building. Flight path is modeled by the equation h of t equals negative 5t squared plus 30t plus 10, where h is the height of the rocket above the ground in meters and t is the time after the launch in seconds. Part A, what is the height of the rocket at time t equals 1 second? Okay, we love ones like this because they're very simple and straightforward. This is asking us to plug in 1. So we're going to take 1 and plug it in the place of the t. So we've got negative 5 times 1 squared plus 30 times 1 plus 10. So negative 5 plus 30 plus 10 gives us 35. So the height is 35, and this is one where we want to make sure we check units. Okay, the height is the, h is the height above ground in meters, so this is 35 meters. All right, let's take a look at the next one. At what time does the rocket reach a height of 50 meters? Okay, notice the difference in those two questions. Part A, they gave us the time and they wanted the height. Part B, they're giving us the height and they want the time. We have the opposite. So in this case, we're going to set 50 equal to our equation, and we're going to solve for the t. Okay, well, we have a quadratic that we have to solve. Big thing here, if we are trying to solve a quadratic, we want to equal to 0, so we're going to have to move this over. We subtract 50, 10 minus 50 gives us negative 40. I'm going to take out a negative 5 because all of those terms, oops, I put a t here, could be divided by negative 5. So that leaves t squared minus 6t plus 8. Now we could factor this one. If we factor, that would be t minus 4 and t minus 2. So that's going to give us t equals 4 and t equals 2. So at t equals 4 and t equals 2 seconds. Now, that's not very well written. So let's make that seconds. There we go. Now, some people will get confused. They'll say, well, how in the world could we possibly have 2 different times where this is true? So here's what you want to think about. The rocket is being launched from the roof of a building, right? So it's going to go up in the air and it's going to come back down, okay, to the ground. So here's what you want to think about. Say we're talking about this height. Let's pretend that's 50, okay? Notice that that goes through your parabola at 2 different spots, doesn't it? So there's 2 different x values, or in this case, t values, that have the same height. So that's how that can happen. Because you're dealing with a parabola, there's two different places that you could have the same height or the same y value. So just kind of keep that in mind. Sometimes you're going to end up with two answers, just like a lot of times we end up with two x-intercepts. Okay, next one. At what time does the rocket reach its maximum height? Okay, so here's something I would think about. It didn't ask us what is the maximum height. Notice that's in part D. All they asked us is what time does it reach it? Okay, I'm going to erase this so I can do some more work out here. So at what time does it reach the maximum height? So think about what we said about our parabolas. If they open, excuse me, if they open down, we have a maximum at our vertex. Take a look at your quadratic. We start with a negative, negative 5t squared. So this is a problem that's opening down because the leading coefficient with that squared term is a negative. So we know that this one is opening down, which means that it has a maximum value at the vertex. Nothing else is going to be higher than that. Now, this one didn't ask for the actual maximum. It wanted to know at what time does it reach the maximum. So that's the t value, which we would normally think of as the x-coordinate of our vertex. Okay, so we're going to have to take our formula to find this. We need to do, oops, I might need to get my pen back. We need to use negative b over 2a. Take a look at your equation. B is 30. So negative 30 over 2 times a. A is negative 5. So that's negative 30 over negative 10, which would be 3. So that's at t equals 3 seconds. Now, what is the rocket's maximum height? Okay, so this is asking for the y value. What is that maximum value? So we need to plug it back in. We need to plug 3 in for our t. Negative 5 times 3 squared plus 30 times 3 plus 10. If we multiply that all out, that should end up giving us 55, and then we want our units, which will be meters. Okay, so the maximum height is 55 meters. Now, there's a couple of things that you need to keep in mind. First of all, we're talking about time as our t, so we're not going to have negative time. So make sure that if you solve and get a negative value, let's say for part B, we had a negative value. We're not going to use that one, okay? So we have to use a little common sense. Also, for part D, when we solved to get the maximum height, we got 55. If we had gotten something, say we'd gotten 25, well, we could have looked back at part A and said, listen, our height at time 1 was 35 meters, so I know the maximum height has to be higher than that. So we would have known that something went wrong with our math. You would want to go back and check something. Just keep those little things in mind, and that can help you from making a mistake or maybe catch some of your mistakes. All right, let's try another one. The power in megawatts produced between midnight and noon by a power plant is given by h squared minus 12h plus 210, where h is the hour of the day. Okay, and the power again is in megawatts. So let's take a look at this one. At what time does the minimum power production occur? So we're looking for minimum. Okay, anytime we see minimum or maximum, we need to be thinking vertex. Okay, now this one is asking at what time? Remember, h is your hour of the day. So at what time does the minimum occur? That's our negative b over 2a. So let's take a look. Negative b. B is negative 12, so negative negative 12 becomes positive 12 over 2 times a. A is 1, so 12 over 2 is 6. Now, this says h is the hour of day. Notice that it said between midnight and noon. So if we're starting at midnight, that would be at h equals 0, right? So if we're at h equals 6, then 6 hours after midnight would be 6 a.m. Okay, so 6 a.m. And then what is the minimum power production? So this is where we want to plug back in. Let's plug in 6 for that h. 6 squared minus 12 times 6 plus 210 should give us 174, and then we are in megawatts for power units. All right, let's try another one. That one was pretty quick. We only had 2 questions. Now we're going to answer 3 questions. Each year, a school's booster club holds a dance to raise funds. In the past, the profit of the club makes after paying for the bank and other costs has been modeled by this function, negative 16t squared plus 800t plus minus 4,000, where t represents the ticket price in dollars. What ticket price would yield a profit of $2,400? Okay, so we have to notice this is the yield of profit. So P is the profit. We want to set 2400 equal to negative 16t squared plus 800t minus 4000. If we subtract that 2400 over, okay, we already had minus 4000 minus 2400 more is going to give us minus 6400. Okay, now we're going to do a little work. All of those should be divisible by negative 16. Let's see what we get when we take that out. Okay, if we take out a negative 16, then we're going to end up with t squared, and then divide positive 800t by negative 16, we get negative 50t. Divide negative 6400 by negative 16, and we get positive 400. Okay, at this point we can, well, actually at the beginning we could have used quadratic if we wanted to, but those are some really big numbers. So if you can take out a common factor, I would try to do that to avoid having to use such big numbers. I can see pretty quickly that there's a way to factor this. T minus 40 and t minus 10. Okay, that would give us positive 400 if we multiplied and negative 50 if we add. So this is our ticket prices. We have two different ticket prices that would work. A ticket price of $10 or a ticket price of $40 would work to give us the profit of $2,400. Okay, part B. What ticket price yields a maximum profit? Okay, notice again, they didn't ask us what the maximum is. It just said what ticket price gives us the maximum profit. So that's our negative B over 2A. So negative 800 over 2 times negative 16, which would be negative 800 over negative 32. If we divide that, we should get 25. So that is a ticket price of $25. And then last part asks us, what is the maximum profit? So we're going to plug that 25 in. Let's see, I'm running out of room here. Let's put it down here. So we're going to have 25 plugged in. So we have negative 16 times 25 squared plus 800 times 25 minus 4,000. If we multiply out, we should end up with $6,000. So that's the maximum profit that school can make from the, what is that, dance. Okay, so $6,000. Those were nice because all of our units were in dollars, which is kind of nice. We like that when it's the same units. Okay, let's take a look now. We have two questions to answer here. Producing music stands, and they hire a consultant to help set the selling for the price of the product. The consultant finds that the profit is given by this equation. We have a quadratic where X represents the selling price of the stands, and P is, of course, your product. Okay, so let's see what we can do. What price should the stands be sold to earn the maximum profit? Okay, so again, maximum corresponds to our vertex. We're opening down, so maximum is going to be the highest point. We want to know what price, X is the price, so we want to know what price would earn the max profit. So this is our negative B over 2A. Negative B would be negative 75 over 2 times A. A is negative 0.3. So that's negative 75 over negative 0.6. If we divide that out, we should end up with $125. Now, next we want to find what is the maximum profit. So we have to plug that $125 in. So we're going to have negative 0.3 times 125 squared plus 75 times 125 minus 2,000. If we plug that in, we should end up with a maximum profit of $2,687.50. So that's their maximum profit off of those music stands. All right, last one that we're going to go through in this video. We need to take a look here. We're shooting fireworks vertically into the air from the ground. The height of the feet of the fireworks is given by h of t is negative 16t squared plus 192t. Okay, part A, what's the height of the fireworks at time t equals 7 seconds? Again, we love these because we're just plugging in. Okay, so we want to plug 7 into the equation. Negative 16 times 7 squared plus 192 times 7. Okay, if we do that, we should end up with, let's see, negative 16 times 49 plus 192 times 7. We're going to end up with 560, and we're in feet. Okay, height in feet. At what time do the fireworks reach a height of 512 feet? Okay, so this time we're setting 512 equal to the equation because they give us the height and they want us to solve for the time. All right, so next thing that we have to do is move that 512 over. So we're going to subtract it. Oops, if I could write, that'd be great. I'm going to see if 512 is divisible by 16 and 192. Are they divisible by 16 so that we can factor it out? Yes, they are. So let's take out a negative 16. That would leave us with t squared minus 12t plus 32. So now we want to see if there are two numbers that would work to allow us to factor, and hopefully we can see those pretty quickly. If not, we can always use quadratic formula. T minus 8 and t minus 4. So if we set those equal to 0, we're going to get t equals 8 and t equals 4. And that is in seconds. Again, remember, we can have two solutions as long as they make sense. If one of those had been negative, then we would not have used it because we can't have negative seconds. All right, part C. At what time do the fireworks reach a maximum height? That is our negative b over 2a. At what time does it reach the maximum height? So negative b over 2a is going to be negative 192 over 2 times a, which is negative 16. So negative 192 over negative 32. If we divide that, that's going to give us 6. So this is at t equals 6 seconds. What is the maximum height? Okay, so let's say we want to find that maximum height. We have to plug the 6 back in. We want to plug 6 back into that original equation. So negative 16 times 6 squared plus 192 times 6. So if we plug in negative 16 times 36 plus 192 times 6, we're going to get 576 feet as our answer. Okay, which again, notice makes sense. We said at time 7 seconds, which is close to where we are, the height is 560, so we definitely should be more than that. Our maximum height is 576 feet. All right, guys. Now, something to keep in mind, you may not be asked every single one of these things in a question. They may only ask part D. They may give you the information and say, what is the maximum height? But you have to know what steps you need to go through in order to solve these questions. Okay, I've given several parts to each one, but if we're talking about maybe a multiple choice or even a fill in the blank kind of question, they're only going to ask you one of these. It's your job to know which one am I trying to do? Am I plugging something in? Am I setting the equation equal to something? Am I solving for the vertex? And what does that look like? Okay, so you always want to make sure, look at those keywords. Is it asking for the maximum or minimum or just where that occurs? And that can tell you, am I looking for the y coordinate when they actually ask for the maximum or minimum value? Whereas if they ask at what time it occurs, that's talking about the x coordinate, the negative b over 2a. Also keeping in mind your keywords as far as what things represent. What do my variables represent? Because that's going to help tell you where to plug in. Think about this problem. We had h was the height in feet, and then t was your time in seconds. Okay, so you wanted to make sure that when they ask you, notice for part A, what is the height? So we know we're solving for h. Okay, so we should have a t value. And then part B, at what time do they reach a height? So they gave you the height, we want to solve for t. Part C, at what time we're solving for t. Again, always knowing what those variables represent can help you a lot as well with figuring out what you're solving for. Okay, guys, take a look at the practice and let me know how you did or if you have any questions.